Welcome to a video on relative frequency. For the first majority of this section, this is going to be a revision of the Year 11 content that we covered in probabilities. So it's just a good recap. We're going to find mean, variance, and standard deviation. And of course, the first one we're going to start with is mean, which is the expected value using the probabilities. So the example that we did in our Year 11 video looked at target practice for an archer with the probabilities that were given. And we changed that into a table that allows us to calculate the expected value or the expected score. So you've got there the target values, the 2, 4, 6, 8, and 10, and the probabilities associated with those. Now remember, to be a probability density, it must sum to 1, which for this it does. Those probabilities do sum to 1. Then to work out the expected score, we need to calculate the x, the score, times the probability. So the first one is 2 times 0.3, which is 0.6. And if we calculate each of the other ones, that's the values for each of those, and the sum of those is 4.5. And that value is our expected value, or the mean, for this data. To calculate the variance and the standard deviation, well, firstly, we're going to calculate the variance. These appear on your formula sheets. A little bit different to how it's actually calculated, but the concept is there on the formula sheet. So all that's missing is for Formula 1, the expected value of the x minus the mean, so mu is the mean value, squared, you times it by the probability, and that's how we get the variance. So let's have a look at our first formula and how that operates. So here's our table. So for each score, we're going to subtract the mean. So the first one is score of 2 minus the mean of 4.5, which is minus 2.5. And if we do that for each one, we don't need a sum for those. Then we square each of those. So the square of minus 2.5 is 6.25. And that's the square of each of them. And then it's the square of those times the probability for each. So the first one is 6.25 times 0.3, which is 1.875. Then we work out that for each of them, add them together, and the sum at the end is our variance. Now, this is a long way to do it, but you could be asked to do this in the exam. The second way is that we square the x's, so we square the scores, times by their probabilities, and then we minus the mean squared. So using our exact same example, we're going to square the score times by the probability. So the first one is 2, square that is 4, times that by 0.3, and you get 1.2. So to do that for each one, you square the score times by its probability, and that's the value you get for each one as you do that. And then we sum that. That gets you 25.4. And then our formula is the sum of the x squared, so that 25.4, minus the mean squared. So it's the sum of the x squareds minus the mean squared. So 25.4 minus 4.5 squared, which is 5.15. So notice you get the same answer. And that's what we should get. It doesn't matter which formula we use. To do the standard deviation, it's simply sigma, it's the square root of the variance. So the square root of 5.15 is 2.27. Now, we have seen recently in our last topic that we can use our calculator to find the mean and the standard deviation, which means the variance is just the square of the standard deviation. That's obviously a lot easier to do, but sometimes you may be asked to use the table or calculate or show how that comes about. So it's important that we understand and recognize how the formula works. For the cumulative distribution, so this will become important in the next topic. The cumulative distribution is that's capital F of X. So PDF, so probability distribution, is lowercase f, and cumulative is uppercase F. So the cumulative just means you're adding your probabilities together. So 0.3, and then you add 0.35 and you get 0.65, and you just keep going along. And of course it should sum to 1, otherwise it wouldn't be a PDF. So if we wanted to find capital F of 8, so the cumulative up to 8, that would be the probability of 2 plus 4 plus 6 plus 8, or the cumulative up to that. So it'd be 0.95. We can also draw histograms and polygons using the P of X, so the PDF, and we can do the cumulative histograms and polygons, or the ogives, drawn using the F of X. Deciles and percentiles or interquartiles, they come from the ogive. When we talk about a discrete probability distribution, so that's just finding the value, the probability at those particular numbers, or the probability of the cumulative can be represented by X less than or equal to the X value. So for the last one, that would have been the probability of X less than or equal to 8 would have been equal to 0.95. And finally, when we look at relative frequency, so using this table, which is actually, we're going to look at this in our next video, but the scores are there, their frequencies, and the sum of the frequencies add to 200. So we convert them to relative frequency. So relative to the total. So 10 out of 200 is 0.05, 54 out of 200 is 0.27, etc. That sums to 1. And then we can do the cumulative frequency or relative frequency. And of course, those sums as you go along, and it should add to 1 as well. Thank you.